All right, you guys, FRQ number 6. Now, this one's a little bit funky. Okay, this is the one where we're going to use a lot of that mean value theorem to justify things. And just to review again, what is the mean value theorem? So the mean value theorem says, if f of x is continuous and differentiable on some interval ab, okay, then there exists a value c in the interval AB so that, and then here's the big little formula, right? F of B minus F of A all over B minus A equals F prime of C. Okay, so that's the mean value theorem. So let's kind of see it in action here. So you have the function f of x equals x to the k minus 3x squared plus 1, where k is a non-zero constant. So look, if mean value theorem is going to be in play here at all, the function has to be continuous and differentiable. Okay, but you guys, this is just a polynomial. All polynomials are continuous and differentiable. The only time you get non-differentiable is if you have like piecewise functions. So this guy is totally good to go. Okay, so let's look at A. So part A says, let k equals 2. Okay, so if I let this little k right here, let me make it a little bit bigger so you guys can see it. If this little k equaled 2, okay, so what would we get for our polynomial? And they're telling you right here that you're going to get this, but if you're wondering how, let me show you, okay? So if k equals 2, we're going to get, I don't know why I wrote this. Let's try again. So if k equals 2, we're going to get that f of x equals x to the 2, so I'm just replacing this k right here with a 2, minus 3x squared plus 1, okay? If I combine like terms, you're going to get 1x squared minus 3x squared is negative 2x squared plus 1. So if you're wondering how the heck they got, oh my gosh, I'm clicking on the wrong things, how they got this negative 2x squared plus 1, that's how, okay? They just replaced the k with 2 and combine like terms. Okay, so I've got that first part. Now it says explain why there must be a value c between negative 1 and 2 such that f prime of c equals negative 2. Okay, so you guys, the first thing, okay, if it ever says explain why there must be a value c, okay, this is kind of like keywords that this is going to be mean value theorem. So I need to check that this formula actually holds, okay? So what do I have here? This is my A, this is my B, okay? My f of x is this right here. So let's go ahead and plug it in. Let's see what I get for this, okay? So let's try it, okay? So you're gonna have f of B, which is 2, minus f of A, which is negative 1, all over B minus A. So I have 2 minus negative 1, okay, is going to equal some f prime of c, which is negative 2. So it's saying this should equal negative 2 because this was your f prime of c. Let's see if that's even true. Okay, so what is f of 2? So if I plug 2 into here, I'm going to get negative 2 times 2 squared plus 1. Then I have minus. Now if I plug a negative 1 into here, I'm going to get negative 2 times negative 1 squared plus 1. And then all over, here I have 2, that's 2 negatives make a positive, so all over 2 plus 1. So let's calculate and see what we get. This is 4 times negative 2 is negative 8 plus 1. Minus, this is negative 1 squared, which is 1. 1 times negative 2 is negative 2 plus 1. So I have negative 8 plus 1, which is negative 7, minus negative 2 plus 1, which is negative 1. And then I have negative 7 plus 1, which is negative 6. And it's all being divided by 2 plus 1, which is 3. So this does, in fact, equal negative 2. So first I had to check that it actually worked. But why does it work? Okay, you have to say, so this was a check, like you got it to work out. But then you have to say, yes, there must exist a value c there must exist a value C because f of x is indeed continuous and differentiable, so mean value theorem applies. Okay, so look, you have to state that the function is continuous and differentiable. You have to state mean value theorem and show that that actually worked. Okay, all right, let's look at part B. So on this one, it said let k equals 3. So for part B, they wanted you to let k equal 3. So let's do the same thing. This time, this k right here is going to be a 3, okay? So I'm going to get x cubed minus 3x squared plus 1. So again, if you're wondering how they got this, they just replaced the k with a 3. And then it says explain why there must be a value r for r between 2 and 4 such that f of r equals 0. Hey, you guys, don't worry that they changed this r, okay? They can call it any variable you want. Usually for a mean value theorem, they call it a c, but in this case, they just called it an r, okay? But you're trying to show here that such that f of r actually equals 0, okay? So how would I do that? So it says explain why there must be a value r between 2 and 4 such that f of r equals 0. So we've got f of x equals x cubed minus 3x squared plus 1. So you guys, let's go ahead and find f of 4. Okay, and okay, I'm kind of thinking about this. I thought for some reason that this was f prime. It's not. It's f of r. So you guys, on this one right here, what does f of r equals 0 mean? Okay, if a function equals 0, that means it crosses the x-axis somewhere right there. If it's going to cross the x-axis, maybe it's got to be below the x-axis for a little bit or above the x-axis. So maybe that works. Let's see if we can give that a shot, okay? So let's go ahead and try to plug in 4, okay? If I find f of 4, that's going to be 4 cubed minus 3 times 4 squared plus 1. So this is going to be 64 minus this is 16 times 3, which is 48, plus 1. Okay, you can actually figure out what this is, but I know that this is a positive number. Okay, so that means that f of 4, my function's like somewhere up here. It's a positive, okay? Now let's see what happens at 2. So at f of 2, if I replace all these x values with a 2, I'm going to get 2 cubed minus 3 times 2 squared plus 1, okay? So this is going to be 8 minus 3 times 2 squared is a 4, and then plus 1. Now, you guys, this is really 8 minus 12 plus 1. 8 minus 12 is negative 4, and negative 4 plus 1 is what? That's negative 3. So that means at the value 2, I'm right down here somewhere. So think about it. Does there have to be a place where it actually equals 0? So if I start down here and I end up down here, do I have to cross through the x-axis? Yes, I do. Now, which theorem said that? That's not mean value theorem anymore. Remember, there was a theorem that said if I start here and end up here, I have to cross through every point in between. Do you guys remember that theorem? That's the intermediate value theorem. So you would say yes, okay? And this is because, now for intermediate value theorem, your function has to be continuous. You guys, this is just a polynomial. All polynomials are continuous. So you'd say because f of x is continuous and f of 2 is negative 3 and f of 4 is, what did we get for f of 4? It's just a positive, right? We can actually calculate when you say it's positive. Okay, so if I'm going from a negative to positive, you can say by the intermediate value theorem, okay, f of r must equal 0 at some point. Okay, does that kind of make sense? So I was thinking, sorry, I wasn't reading it at first, but I was thinking this is going to be mean value theorem again, but it was not. Okay, and then the last one. It said let k equals 4. So again, if I let k equal 4, so if this value equals 4, you're going to have this polynomial. Write an equation for the line tangent to the graph of f at the point whose x-coordinate is 2. So you guys, this one is just a good old tangent line question. So let's look at C. So we've got the polynomial. So rewrite it over here. F of x equals x to the 4th minus 3x squared plus 1. And we want a tangent line to the graph of f at the point whose x-coordinate is 2. So I know that x equals 2. Okay, so if we're doing a tangent line, remember we want two things. We want a point and we want a slope. So the point that I have is x equals 2. I need to find the y value, which means I need to find f of 2. So that's going to be 2 to the 4th minus 3 times 2 squared plus 1. Just replacing all of these x's with a 2. So it's going to be 16 minus 3 times 2 squared is 4 plus 1. So this is 16 minus 12 plus 1. So that's 4 plus 1, which is 3. So my point is 2, 3. Now, how do I find the slope? Remember, a fancy name for a slope is just derivative. So if I find f prime of x, so the derivative of this polynomial is going to be 4x cubed minus 6x. Remember, the derivative of 1 is 0. So you guys, I want everything to happen at x equals 2, right? Did they say x equals 1? Oh, so x equals 2. Sorry, I'm misreading everything today. So this is f prime of 2, which should be 4 times 2 cubed minus 6 times 2. So this is 8 times 4, which is 32, minus 12, which is 20. So here's my point, here's my slope. Putting it together, I'm going to get y minus y1 equals m times x minus x1. So y minus 3 equals 20 times x minus 2. Is that what we got? Y minus 5. How did they get y equals 5? Hang on a second. Did I mess it up? You guys, I give up. 16 minus 12 is 4. 4 plus 1 is 5. Okay, I think I should like literally retire right now. Let's try that again. Does that make sense? Okay, awesome. There's your answer. All right. Okay, so you guys, that's number 6, and we're almost done.